Hey guys, it's Mark from the Abstract. In this tutorial, we're going to discuss intervals and their functions a little bit further. As you can see in this session, I have loaded 4 separate tracks, each with a MIDI region that contains a different interval. One has a major third, one is a perfect fifth, one is a minor sixth, and one is a major seventh. I've started them all in different keys to show you how if you were to change keys, the relationship between the interval we're on will not change. Only the key will change. So let's start with a major third. Right here we have a major third in the key of F. F, A. I'm going to go ahead and mute these other tracks so when I play it's not going to get in the way. But let's hear what a major third sounds like. It's a very happy sound. Now what makes up a major third and what makes up all intervals are the distance between the first and the second note. The distance between these two notes is made up of 4 half steps. Let's analyze. If we start on F and we travel up 1 half step, we get here to F sharp, then to G, then to A flat, then to A. So F to F sharp is 1 half step, F sharp to G is 2, G to A flat is 3, or G sharp, and G sharp to A is 4. So let's play it again. You'll hear the major third quality, and this is in the key of F. So let's say I wanted to change keys from F to the key of D. All you have to do, and this is very easy, Logic makes it very easy, you grab both and you grab the bottom note, you bring it down to D, and the relationship will not change. There's still 4 steps separating the bottom note from the top note. D to D sharp is a half step, D sharp to E is a half step, E to F, half step, and F to F sharp. Let's hear how this sounds. It still sounds like a happy sound, just like F to A did. Let's change the key one more time. We're going to go up to the key of A. And now the relationships are A to A sharp is 1, A sharp to B is 2, B to C 3, and then C to C sharp is 4. This sounds pretty similar. So this proves that no matter what key you're in, if you maintain the same interval, the same amount of steps between both of the notes, you're going to maintain the same interval. So let's move to another interval. Let's go to a perfect fifth. So I chose to do this in the key of B. B is our starting note, and this is our top note. To travel to this note, we have to travel a certain amount of steps. Let's count. B to C is 1. C to C sharp is 2. C sharp to D. D to D sharp to E. E to F. F to F sharp. There were 7 half steps in that interval, and it sounds like this. So now I'm going to maintain the 7 steps, but I'm going to change keys. I'm going to drag this up to E flat, which is this note right here. And before I even count the steps, you're going to hear a similar quality between the 2 intervals. So let's just count the steps to prove that we do indeed have a perfect fifth. E flat to E is 1, E to F 2, F to F sharp 3, F sharp to G 4, G to G sharp 5, G sharp to A 6, and A to A sharp or B flat is 7. Whereas before, in the key of B, sounded like this. So you hear the quality of the chord, or the quality of the interval, did not change. Just the key did. Let's move to the next interval. Minor sixth. So right now you notice right away that I don't have a minor sixth. So I'm going to create one. We're going to do it in the key of G. So we noticed that a perfect fifth had 7 equal half steps. To get a minor sixth, all we have to do is travel 1 more half step up from where we were, thus being 8 half steps. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So this note should be right here. And it'll sound like this in the key of G. Now I want to change keys to the key of C. Move everything up, and let's play it. So even though we change keys, you can still tell it's a minor sixth. What I encourage you guys to do when you're at home is to spend time acknowledging what these intervals sound like. A one-time pass is not going to do it. You have to spend time differentiating these sounds so you can be able to identify them way easier in a real session. So far we've been dealing with consonant intervals. Major third, perfect fifth, minor sixth. Remember, a consonant interval is an interval that sounds like it fits together. And so far, the three of those did. But now we're going to move to an interval that does not fit together. It creates a sharp awkwardness and offness. You'll hear what I mean. We're in the key of C, and this is a major seventh interval. There's something weird about that. Now, when you start writing music, you'll understand that major sevenths are very cool in certain cases, especially when you have a full chord with a major seventh on top. But for now, when you just separate the root, which is the C, from the seventh, which is the B, it sounds very weird. But let's change keys. If we're weird in the key of C, what's to stop us from being weird in the key of A? So I moved everything to the key of A, and we should have the same relationship. Let's count how many steps make up this interval. So we got A to B flat is 1, B flat to B 2, B to C 3, C to C sharp or D flat 4, D flat to D 5, D to E flat 6, E flat to E 7, E to F 8, F to F sharp or G flat is 9, G flat to G is 10, and lo and behold, G to G sharp is 11. A to G sharp is the interval. It's a major seventh. Sounds off, just like C to B did. Let's change it to the key of F. Still going to maintain the same dissonant sound. Now, to some people that may sound cool. I think it sounds cool, but to the untrained ear, it definitely sounds a little dissonant. So, that's a little bit more about intervals and their relationships. Just remember, the interval will stay the same if you keep the distance between the two notes the same. The key does not matter. So remember that, and let's move on to the next lesson.